When space on the ground is limited and money's no object, then building upwards is the only solution.
In this programme, we explore the first true British skyscraper, the Royal Liver Building in Liverpool, and travel to Frankfurt in Germany to visit the tallest office building on the continent, the ultra-modern Commerzbank. But we begin in Tuscany in Italy, where 800 years ago the quest for height really took off.
The problem in engineering tall buildings is how to make them strong enough to carry their own weight and the huge forces from the wind trying to blow them over. Like this tree, it's a question of stability. As they get taller and taller, they're more and more exposed to the wind, and it gets more and more difficult to support them at the base. In masonry, this is a particular challenge.
These are the spectacular medieval towers of San Gimignano, rising above the rooftops of this beautifully preserved town in the Tuscan hills of northern Italy. 15 of these towers remain out of an original 72, each one the result of merchant wealth and family rivalry back in the 13th and 14th centuries.
Tall buildings are an expression of wealth and status, and by the 13th century, San Gimignano had become one of the most prosperous towns in Europe. On the main route from northwest Europe to Rome, the town was busy with pilgrims and merchants. It was a centre of the textile trade. The piazzas would have been bustling with people in the finest jewellery and fabrics.
The towers were commissioned by the richest families in the town, and they competed with each other to build the tallest. The various towers each had different uses. Some were used as campanili or bell towers, but essentially they were fortified dwellings, safe places of refuge in times of war.
The Palazzo del Podestà was the seat of municipal government and was built at the end of the 13th century. At that time, the town was self-governing, an independent city-state.
The palazzo is dominated by the Torre Grossa, the great tower which is decorated by the arms of the various podesta, or mayors, who held office during its construction.
The building design is actually very simple. Like the other towers in San Gimignano, they're all roughly square and hollow, like this tube I've made from a postcard. The walls are about as wide as they could be without any internal bracing. If the walls were much wider, then towers like these would be at risk of collapsing from the wind. So the square shape is a very strong shape, provided the walls are thick enough.
The walls are actually made of brick, but faced on the outside with a local limestone called travertino. These holes were for wooden scaffolding used during construction.
The tower has 4 massive walls, which are thicker down here near the bottom than at the top. The thickness keeps the stresses in the stone low, but more importantly, it stops the wall from buckling under the weight of the walls above. Having such a large base gives the whole tower stability against toppling. The tower had wooden floors. The joists supporting the floors sat in these larger holes here, but the floors didn't provide any additional support for the tower. In modern buildings, the floors often provide extra bracing, tying the 4 walls together. But here it's clear the floors had no structural significance because they've gone and the tower is still standing. Up here at the top, the wall has thinned down. The tower is an amazing 54 meters high. That's the equivalent of about 15 stories, near the limit of what's possible in brick or stone. In fact, it's only possible with this design because of their compact shape. They're an amazing sight.
By the mid-14th century, more than 70 towers had sprung up all over the town. It must have been like a medieval Manhattan. It looks peaceful now, but there was intense rivalry and deep divisions between the families. Feuding was commonplace, particularly between the two great families, the Ardenelli and the Salvucci.
These twin towers were built by the Salvucci family. The city rules insisted that no tower be higher than the Great Tower, so, undaunted, the Salvucci family built two, the idea being that their combined height far exceeded anyone else's. However, if they had built one tower that high, it wouldn't have stood up anyway, because it would have been too slender for its height.
They stood next to their palace, which was burnt down in 1352, as the war between the two clans entered its bloodiest phase.
Fighting between rival families was just one part of San Gimignano's eventual decline. The town's population was decimated by the Black Death in 1348. Trade and pilgrims moved away, and the town lost its independence to Florence. It was only in this century that its fortunes picked up again with the arrival of large numbers of tourists.
The towers here were extraordinary for their day. The principles of their construction were simple but effective, based on experience rather than formal design methods. The fact that there are so many of them reinforces the atmosphere of commercialism and competition, everyone straining to outdo their neighbors.
At the end of the day, there's only so much you can do with stone. Traditional masonry buildings rapidly reach a limit in height when the external walls become unfeasibly thick because they have to support their own weight and the ever-increasing wind load. To build much higher than this, the walls at the bottom would have to be so vast there would be no space inside. It was only with the emergence of new materials in the 19th century that the development of the skyscraper as we know it truly begins. Although the details changed, basic building systems remained much the same for several hundred years, until the end of the 19th century. Then, the quest for height in Europe entered a new phase in places like this, Liverpool, a busy and prosperous international city.
This is the Royal Liver Building, widely regarded as Britain's first skyscraper. It was built for the Royal Liver Friendly Society, an insurance company who wanted a new headquarters which would reflect their role as insurers in one of the world's busiest ports.
Then, like now, this was one of the main points of entry to England from America, and the society must have aspired towards the new tall buildings that were all the rage in New York and Chicago.
The building is a 10-story office block with two 6-story towers on the roof, giving a total height of 322 feet. Although its height is not unusual today, for 20 years after its opening in 1911, this was the highest building in Britain. The birds gracing the top are livers, a mythological bird said to have haunted the area.
The building is famous as a symbol of the city, but the attraction for me is its engineering. The Liver building was at the forefront of a new generation of European skyscrapers, which had a radical and innovative structural design. Unlike San Gimignano, the walls of this building don't have to carry the weight of the floors above. Instead, there's a frame inside which supports the whole structure. A frame is like a skeleton carrying the forces from bone to bone and eventually down to the ground. So the frame takes the weight and the walls are simply protection from the elements. The frame has another advantage. Using columns means that the space inside can be left empty, giving us the familiar open-plan office. This was the great advantage of frame buildings. Big open spaces, which had previously been a luxury, were now accessible to everybody. The frame in the Liver building is made of reinforced concrete with steel bars embedded in it to give it extra strength. In Europe, at the end of the 19th century, the technique was pioneered by François Hennebique, a brilliant French entrepreneur whose designs quickly became standard practice. This was an Hennebique building.
The concept of the frame speeded up construction too. In fact, the building time for the frame averaged just 19 days per floor, an amazing achievement. Once the frame had been built up, work could start on the walls of lots of floors simultaneously.
The walls of the building are made of granite, 25,000 tons, mainly from Norway. The weight of granite helps to keep the building stiff. At the bottom, it's fine cut, but up here at the top, it's much rougher. Part of what makes skyscrapers possible is the services within it. A high-rise building couldn't be successful unless you can move the people up and down. So the invention of the lift by Elisha Otis in 1853 was critical to the evolution of tall buildings. And this is the lift motor room.
These are the original motors from 1910. They carry 6 lifts, and there are 4 more in the front of the building. This is actually fewer than in the original design because lifts are now much more efficient.
Other services are just as vital, such as controlling the temperature inside the building to keep it comfortable. This light well, one of 2 in the center of the building, provides light and ventilation throughout. This was in the days before air conditioning, of course.
Skyscrapers are also about showing off, as here in Liverpool, to the arriving passengers on the liners from America.
I'm directly behind one of the clock faces in the West Clock Tower. They each have 25-foot diameter faces. That's bigger than the clock face on Big Ben. But as for the bells, well, look, there aren't any. So how do the clocks chime? This is a bell tone generator dating from 1953. It's connected to a system of amplifiers and speakers, and it should be going off any second now.
The significance of the Royal Liver building is that it marked the arrival of the concrete frame. It was a turning point in building construction, freeing up designers in an unprecedented way.
It might not look like a skyscraper now, but it was immensely tall to people then. Most importantly, it's a building which has all the elements that are important today. The concept of the frame, the lifts, a safe and comfortable working environment for the occupants. It was a blueprint for the future. But the Edwardian engineers could only have dreamt of where we're going next.
This building in Frankfurt, Germany, is the new headquarters of the Commerzbank. At 299 meters, it's the tallest office building in Europe. Its triangular shape was designed by the British architect Sir Norman Foster. The 56-story tower stands next to the bank's previous headquarters in the center of Frankfurt.
Despite its immense size, it fits quite comfortably with its surroundings. It seems to grow quite naturally out of the lower buildings around it. The modern building in front was designed to help it blend in and was in fact part of the scheme.
The main entrance is fully exposed to the street. Many floors have garden areas. It's a comfortable and popular working environment.
The main challenge with skyscraper design is to make them stiff enough to resist the wind, because wind forces increase rapidly with height. The stiffness of the Commerzbank comes from its rounded triangular shape. The Commerzbank is made up of 3 separate towers, one at each corner. Linked together by giant crisscross beams where the offices are. The effect is like 3 tubes bundled tightly together, which gives them much more stiffness when the structure tries to bend or is pushed over. The giant beams which join the towers at each corner are a special form of truss called a Vierendeel beam. Instead of the bars being diagonal, as in a conventional truss, they're horizontal and vertical. The main advantage of the Vierendeel beam is that the windows aren't obstructed, as they would be with diagonal bracing.
Conventional skyscrapers are built around a structural core in the middle of the building, but here the tubular towers at the 3 corners provide the main support. So in the middle, they can have a great atrium right to the top. That means the lifts are pushed out to the corners.
They've got some really fast lifts here. These ones go at 6 meters a second. There's a second challenge with modern buildings too. The Commerzbank had to satisfy the requirements of the local government in Frankfurt. They imposed a whole raft of environmental conditions to improve the energy efficiency and working environment of the building. This made the Commerzbank the first true eco-tower.
Buildings in Europe account for over 40% of all energy consumed. So in this building, the engineers paid particular attention to ways of reducing power consumption, but at the same time making the Commerzbank an attractive place to work.
The concept of the tower was to provide a light and spacious working environment. It's divided into groups of floors, like villages, each with access to its own separate outside garden space. Everybody has a view. The offices on the inside of the building look down on the garden, and those on the outside look out over the city. It's a great feature, both on a social level and for ventilation.
The central atrium controls the flow of air in through the garden and up and out at the next open level. There are ceilings every 12th floor for fire protection and to prevent strong updrafts from forming, which would spoil the tranquility of the open spaces.
This is the immediate difference you see compared to a normal air-conditioned office block. You can open the window. Here I am, looking down on my own garden space. Lovely.
And it's even more impressive when it's 20 floors up. But most importantly for the staff, with access to light and fresh air, no matter where you are in the building, it's a very attractive place to work.
On the other side of the building, the windows are also openable, but they have a second outer glass skin for weather protection. But it's still fresh air, and it comes up through the big gaps just here at the bottom of the window. There are conventional heating and cooling systems too, but for 60% of the year, the building is naturally ventilated, which is quite remarkable.
This is also one of a new generation of intelligent buildings. Computer-controlled systems can open and close the windows, reduce the lighting when it's not necessary, and move the lifts independently to more efficient positions.
People have talked about building skyscrapers a mile high. There's no doubt that with the knowledge and experience engineers and architects now have, there are no technical obstacles to that dream becoming a reality very soon. It's the design of buildings like this which will point the way. The construction of tall buildings is about self-importance, showing the world who's biggest and best. But in San Gimignano, Liverpool, and here in Germany, the quest for height has produced grand buildings of great beauty and vision. Skyscrapers are one of the most exciting challenges for civil engineers, and truly, the sky's the limit.
In the next program, we travel to Sweden to marvel at the most powerful wind turbine in the world, explore the largest pumped storage hydroelectric scheme in Europe at Dinorwig in Wales, and get close to the ultra-high temperature technology of the Adela solar furnace in the south of France.